All right. So as I was saying, I just want to welcome you all to Engineering World Health's first webinar of this series that we're doing. This one is on challenges to medical equipment maintenance, specifically in low resource areas and all of the areas that we work. So a little bit of background about Engineering World Health, if you are not familiar with it already. We are a nonprofit organization. We're based out of Durham, North Carolina, but we work all around the globe. And our primary mission is inspiring, educating, and empowering the biomedical engineering community to improve healthcare delivery in low resource areas. So we do that in a whole bunch of different ways that I'm going to talk about in our webinar today, as we sort of get into all of the different challenges and things that we've seen during our work. So just a little bit about me first. My name is Megan. I am a program manager with Engineering World Health. So I sort of got into this field, got interested in this area during my undergrad, where I studied biomedical engineering as well as international studies in Virginia. In my time as a student, I actually worked with Engineering World Health in Rwanda and interned as a biomedical technician in Rwanda, as well as in St. Vincent and the Grenadines, sort of independently. Then ended up becoming a biomedical technician in the US. So I repaired medical equipment all up and down the East Coast for various hospitals, healthcare centers, surgical sites, and things like that, before becoming a project manager with EWH. Since then, I've had the privilege of working sort of all around the world. I've worked and led programs all throughout East Africa, so in Rwanda, Uganda, and Tanzania, as well as spent quite a bit of time in Southeast Asia, working in Cambodia, and I've worked on in our locations in Dominican Republic and overseen our programs in Guatemala as well, and Nepal. So had quite a bit of time to sort of get accustomed to what it's like working in healthcare, specifically with medical equipment, and working with medical equipment in low resource areas, which is really our focus for this evening's presentation, if it's evening where you are, or joining from wherever you're located. So a little bit about the places that Engineering World Health works. I named a whole bunch of countries right there in terms of like places that I've been, but EWH has a number of ongoing and completed projects sort of all around the world, as you can see from our map here. So we've got a number of ongoing programs, which you can see from a lot of the orange countries here, as well as programs that we've run in the past and have since completed. And these vary, everything from student programs to programs specifically for biomedical engineering technicians and training programs for them. And we'll get into that a little bit more as well. But as you can tell, even though we're based on the East Coast in the United States, our global reach is pretty expansive. And that's something that we really take pride in, and is a really big focus of our work. So that's something that we'll definitely be continuing and highlighting as we go along. So during our time working in all of those countries, we've been working in primarily medical facilities. So while we work with universities and different schools and everything as well, our really main focus with a lot of our programs is improving healthcare conditions. And the way that we do that is through medical equipment repair. And so for a lot of these scenarios, we take students to repair medical equipment with us and train with us on how to do this. And so some of the numbers that we've gotten over the past over a decade of doing this, we've had over 1,100 participants since 2004. So those participants being largely undergraduate and graduate students, as well as like young professionals who will come and travel with us and repair medical equipment and work in low resource settings, and volunteer in hospitals. What we found is that we've done over 12,000 repairs on all types of medical equipment, supporting 8 different countries in those programs and servicing basically $25 million worth of equipment. And so that's all sorts of equipment that either was broken or out of use for various reasons that our students or our volunteers were able to get back up and running and put into service. And what I really want to talk about today is sort of why that sort of work is even necessary, what the process is to make that happen, and what are some things that we as engineers or as other personnel involved in global health initiatives can do moving forward to sort of address this as a larger global problem. One of the things that we look at is the situation as a whole. So World Health Organization study found that 40 to 70% of hospital equipment is out of service in the developing world. Now that's a pretty broad range, but one of the biggest reasons that we're seeing that is because even when hospitals have the resources to hire technicians, it might be difficult to find certified biomedical equipment technicians due to a lack of access to training in these areas or a whole bunch of other problems. So this is an interesting picture that we've got because what you're actually seeing here is a group of our students who were spending time in Nicaragua. And in the background here, you see all of these different machines. And these are actually infant incubators at a hospital in Nicaragua. So you've got, probably a half dozen different infant incubators, which, at some point or another, the hospital either purchased or were given or got through the Ministry of Health, but they're completely out of use. And behind it, you can see all sorts of things. You've got wheelchairs, you've got beds, you've got stretchers, you've got all this different medical equipment just sort of piled up. And, while this picture is a little bit shocking and it's sort of like, well, is this the case everywhere? What we found is that this scene here of just having piles of unused medical equipment is not at all uncommon in the areas that we work. And this is actually something that that we call an equipment graveyard. And you see this in a lot of really low resource areas where equipment for one reason or another is physically at the hospital, but it's not in use. And then you have hospitals that end up having to store it and have an entire room that's or storage area that's fenced up like this and they have to put all this equipment outside and it's just sort of there sitting, potentially even costing the hospital money to sit and deteriorate there. And you just see tons and tons of equipment that goes basically to the wayside and is completely unusable. So in order to sort of look at why this is happening and why specifically this situation is happening in low resource areas, we really want to talk about, what is defining a low resource area as opposed to a high resource area. So one of the really big things that we look at is that in high income countries, when a piece of equipment breaks down, the really easy way to go about it is you can either order a new component from the manufacturer or you can buy an entire new machine. And that's sort of what you see in the United States, as well as a lot of other high income countries is biomedical technicians will be trained to do certain repairs, but all of those repairs basically require swapping out boards or swapping out different components. And there's not a lot of repairing the components that are in place on the board. It's much more a process of swap a piece out or swap the entire unit out. Obviously, that option is not always available in low resource settings. So the vast majority of medical equipment that is being produced in the world is coming from high income countries, such as the United States, such as Germany, such as Japan. And much of the equipment found in low income countries or low income country health centers and hospitals might be donated. And so those healthcare centers and hospitals don't have access to customer service. They don't have access to the same user training. They might not even have access to instruction manuals. And it's generally much, much more difficult to get somebody to come out and service your equipment if the equipment wasn't manufactured in that country. So you see a lot of different struggles that are all sort of focused around certain countries not having access to the same resources, not having access to availability of parts and things like that would make a repair quite easy in a high income country. That repair becomes really, really difficult in low resource areas. And sort of that. And so when we're talking about medical equipment specifically and talking about and like repairing medical equipment in these countries, that's a really important metric that we use when we're discussing is, do these countries have, or do these locations have access to spare parts? Do they have access to do quick repairs of components, or are we looking at scenarios where a repair might require a really expensive part to be mailed in, and that increases the cost, et cetera. And we're going to talk about that a little bit further as well. So in low resource areas where pieces of equipment might be donated or might be secured secondhand, what does that scenario look like? Well, it's actually a pretty staggering statistic, because what EWH has seen in its time operating is that a lot of the times in low resource areas, when medical equipment arrives, either as a donation, mostly as a donation, you end up seeing that about 39% of it arrives completely unusable. So from the time that the equipment reaches the hospital, about 39% of it is not able to be used by hospital staff. So obviously that's going to knock out a pretty staggering amount of equipment that's available to that hospital or healthcare center. And there's a variety of reasons for this. You're going to have equipment that's shipped with defects. You're going to have equipment that's shipped with missing components or consumables. You're going to have equipment that isn't able to be used in that hospital because of different power supply issues, or there's various scenarios where maybe a piece of equipment works perfectly fine, but it wasn't shipped or it wasn't sent to the hospital with a manual or any sort of user training. So hospital staff don't know how to use that piece of equipment, which leaves us with about 60%, 61% of donated equipment that's able to be used when it arrives. But even further, what we found is that after 5 years, another 58.5% becomes dysfunctional. So obviously, that's leaving a super small amount of equipment that's functional after 5 years. We're left with just about 2.5% of initial donations of medical equipment that are still operable and in use after 5 years, which is a really, which is a really staggering statistic. And unfortunately, so this is another picture of an equipment graveyard. And you can see all kinds of things in this situation. You've got at the back here all kinds of different stretchers and beds for patients. At the front here is a bunch of sterilization equipment. So we've got parts of water tanks. We've got autoclaves back here, which are used to sterilize medical equipment. We've got suction machines down here in the front, a bunch of drawers and furniture and tea kettles and things like that. To the left side here, we've got more sterilization equipment. So these are tins that are used within autoclaves to sterilize equipment, to sterilize like surgical tools and things like that. And all of this equipment is sort of out of use. And unfortunately, this is just a scenario that we have hundreds of pictures of. It's something that we see at nearly every site we work, is that there is an area where there's just a staggering amount of medical equipment that's out of use. And there's a whole bunch of reasons for it, some of which I just commented on, but more that I want to get into. So basically, why is this happening is the really big question that we want to hit. And obviously, there's a list of reasons. We've got costs, we've got BMET training, the donation process that we were talking about, spare parts, tools. But what I want to focus on first is sort of exactly what I was talking about, the donation process, as well as access to spare parts and tools. So of all that equipment donated that I was just talking about, a lot of it will end up being shipped with defects, maybe not even that the donor understands is a defect. So there will be a lot of situations where really, really well-meaning donors or people or groups will collect equipment that maybe they're not using and can be sent overseas to another country somewhere. So these tend to be like different, honestly, different nonprofit groups. They tend to be, they can be religious groups. They can be different hospitals who are trying to donate equipment that they're not using, who maybe want to donate it to a different NGO or nonprofit to take it somewhere. There's all sorts of different groups that are using that send equipment to other countries for use by lower income areas. And most of these groups are super well-meaning, but what we find is that there's just a basic lack of understanding about the needs within low resource areas, and the equipment that's being sent to these areas. So you'll get equipment that is shipped with defects. Obviously, that is a really big problem. But you also get equipment that's just shipped with missing components or missing consumables. And part of the reason that we see that is because there's a lack of understanding about what's needed on the receiving side. So if you have, let's say you have an electrosurgical machine, something that's used to perform surgeries, that's used to cut and cauterize and work really actively on a patient, that's something that in the United States, there's different tips that go on this electrosurgical machine to prevent infection and things like that. So it's got these disposable parts that get thrown away after every single surgery, all to prevent infection. And this makes a lot of sense in our environment. But if you donate, for example, an electrosurgical machine, but you don't donate a recurring number of tips, a recurring number of that consumable part to go with the machine, then after a certain amount of time, that whole machine is going to become unusable because they don't have the disposable part to go with it. And so there's a lot of situations like that where maybe the tips for this machine specifically are really hard to access, or maybe because it's an older model, you can't get the consumable part that goes with it. This is one reason why you'll see equipment go out of use. Another reason is missing components in general. So if you donate the machine, but maybe forget to pack the power cord with it, simple mistake, it happens. But unfortunately, maybe the hospital really has no way of getting that power cord. It'll just sit and never be put to use. Even if the machine itself, even if you have a patient monitor or something that's in great shape, but you forgot to include the cord with it, that'll sit and just deteriorate until it's no good to anybody. Similarly, there can be a misunderstanding about the infrastructure of the area that donations are being made to. So if we take that same patient monitor that is being donated from the United States, for example, and we donate it to a hospital in Uganda. In the United States, the voltage coming out of our walls is you have 110 volts coming out of our walls. In Uganda, you've got 220 to 240 volts coming out of their walls. So unless you're also donating a transformer with that, what you're going to see is if that machine gets plugged in directly into the wall, there's going to be a power difference there. You're going to have capacitors that blow up. You're going to have all kinds of different issues with compatibility, and just because of the region that it was made in and the region that it's going to. So a lack of understanding about the conditions in the hospital, just specifically relating to infrastructure, can lead to a lot of this equipment going out of use as well. Similarly, I think I mentioned a little bit earlier, manuals and user training are a really big deal. So if you donate a device that's fairly complicated or isn't necessarily the most user-friendly item, we saw this a lot with ventilators, especially now in the era of COVID, where ventilators were in very much high demand. Certain ventilators have different settings. They have all sorts of different training that's required as you work with different ventilators. A group could get a bunch of new ventilators, update their whole hospital, and then donate their old ones. But if they're not donated with manuals and user training, especially if they're done in a different language or something like that, a lot of times you'll end up giving the device to staff on the other side who don't know how to operate that particular model. And it ends up with equipment once again sort of being put to the side and not being used because staff can't really access a lot of the materials needed to get that training. Also, if that device is older, maybe tech support doesn't exist for it. So it could be a simple thing, could be a piece of software. Maybe the group needs a password to get through the software on that device. But if tech support has gone out or is no longer supporting that device, or is unwilling to support a device because a hospital was not the one who purchased it themselves, which we see a lot, that's a reason why a lot of equipment will end up not being able to be used as well. And then finally, we have no access to spare parts, which is a huge deal as well. We'll see a lot of scenarios where hospitals might have a surgical light or something like that in any regular or in any like high income country, this would be a really easy repair. Maybe you just need to repair a light bulb or replace a light bulb, and that would get the device up and running again. But that light bulb that would cost $1.25 in the US, you can't get easily shipped to a hospital in rural Rwanda. So all of a sudden we're having to try and find someone to ship it, and the shipping costs is $150 for a light bulb that would have otherwise cost $1.25. And so we see that a lot is if you have parts that are specific to a certain device, not having access to those parts becomes a really difficult point for biomedical technicians or other hospital staff to try and overcome to maintain their equipment. All right. And so this is sort of reiterated in this slide as well. So while more generic spare parts might be easy to find, specialized parts such as specific light bulbs, printed circuit boards, or other things are challenging, if not impossible, to find and replace. So even if the part is very inexpensive, if it can't be found in country, it can cost hundreds or even thousands of dollars, and it can take months to arrive just to have it shipped to the hospital. So really specifically parts that need to be ordered from a specific manufacturer or dealer sometimes just become totally inaccessible because if you have, a repair that should take just a few minutes, but it's going to take months for it to get on a shipping container and then over and delivered to the appropriate hospital. This is one of the many reasons why equipment can be taken out of use. So continuing on that note, some of the other issues that we see is cost and what it takes to sort of train and certify biomedical technicians. So why is it so difficult for biomedical technicians to maintain equipment? Aside from all the issues that we just talked about, hospital technicians don't always have the time or the budget to go looking for all those spare parts that we were talking about, even if they do exist in country. So it's not uncommon for technicians to also be responsible for keeping an ambulance running or maintaining the airflow and maintaining all the lights out at the hospital, and be responsible for a whole bunch of other maintenance or other tasks. So when hospital technicians don't have access to the necessary spare parts and they're not easily at hand, the equipment falls out of service and doctors aren't able to properly diagnose and treat patients. So obviously there's a really big trickle down effect. When you see equipment that goes out of use, you're not going to be able to treat patients well. So while technicians in the United States or other high resource areas might only need to be trained in doing certain repairs where they can swap out spare parts, and repairs are done pretty quickly and they can get in and be out and do the job, we end up seeing that a lot of biomedical technicians in low resource areas have a lot more on their hands. So to be truly effective, equipment technicians not only need to have the technical skills that we're talking about, or even further advanced technical skills than you would need in a high resource area, but they also need to have creativity and patience. They need to have familiarity with the political and bureaucratic landscapes of their hospitals and healthcare systems. And they also have to have the diplomatic skills for working in a hospital with many wards and departments, and able to navigate all of that and advocate for their own needs. So success in maintaining medical equipment ultimately depends on not just that technical skill set, but it really depends on a biomedical equipment technician having active communication, collaboration, and trust. So in our experience, what we've seen is that in order to be a really highly qualified biomedical equipment technician in a low resource area, you need advanced skills in a lot more areas than we would consider working in a high resource area. So in addition, we were able to touch already on the user training and manuals. I also want to talk a little bit about reliable electricity and clean water for equipment that takes certain power, that has certain power requirements, or maybe needs a certain type of water, whether that be distilled or whether that be deionized or anything like that. having access to that sort of equipment and having the infrastructure for consistent, reliable electricity and things at the hospital can be a really big factor. And I think these are two areas that our minds sort of go straight to when we're talking about, high resources versus low resource area, or developed versus developing areas. Is, we get this image of like people without access to water and things, and that's not always the scenario, but it can definitely affect performance in hospitals if a hospital doesn't have consistent electricity to their healthcare center. You might have equipment like an infant incubator that even a quick power outage or a quick power surge cutting off and before the generator kicks on or something like that will cause the unit to like reset, and then the nurses or other hospital staff will have to go in and they'll have to change the temperature on every unit and things like that. So it just ends up being a lot more energy that staff have to exert into maintaining the equipment itself. And there's all sorts of issues with that because of equipment that's designed to be used around reliable electricity. It's designed to be used with consistent clean water, or access to consistent sterile water and things like that. That just adds an extra element that staff have to account for and sort of make up for on their end. And finally, you get brain drain, and I won't dive too deep into this because it can be an entire webinar on its own. But a lot of the times what we'll see is we talked about the qualifications that it takes for a biomedical technician to be really highly skilled. A lot of the times when you have staff who are overworked because they're having to overcompensate for a lack of resources or things like that, you get your most highly skilled people who end up searching for work elsewhere or looking for jobs elsewhere. So you'll get biomedical technicians or other engineers who will go and get really high levels of training in their field, and then they become able to be employed in other countries, and people will leave basically their home country and go work elsewhere. And this definitely does contribute to not just biomedical equipment, but to development as a whole. It can be one of the contributing factors to struggling with like the advancement in any field. So if your most highly skilled biomedical technicians end up even all going to the capital city, because that's where hospitals are able to pay them the most, you end up with rural areas all around the country who don't have highly skilled biomedical technicians, and then they end up struggling further, and it's an unfortunate cycle. So what does this mean for hospitals? What does this mean for healthcare centers and the larger effects on healthcare? As you can imagine, if a hospital doesn't have a piece of working medical equipment, you can't do the procedures that piece of equipment is designed for. So if you would consider like showing up to a hospital or to your local clinic or something with a broken leg, and the hospital tells you, I'm sorry, we can't treat you because our x-ray is down, that's gonna be a pretty big deal. You're either going to have to wait for a really long time to get treatment, or you're going to have to travel really, really far to get the treatment that you need. So obviously you're going to have negative outcomes, and safety is compromised. But what you're also going to see is that, hospitals make money by doing procedures, right? The money is either coming from the patient, or it's coming from insurance, or it's coming from some agency. And if a patient needs to go and travel to a different healthcare center because your healthcare center can't treat them, you're going to end up having not only like reduced efficiency, but you're going to have reduced revenue. And when that happens, where are you going to get the money to repair your x-ray machine if all of the patients who needed it and that device would have been used on aren't able to bring income into that hospital? It obviously becomes a pretty negative cycle where sometimes the hospital with the lowest number of resources end up not being able to generate revenue for themselves, and aren't able to get sort of out of this cycle of not having equipment that works, not being able to perform procedures, and not being able to continue offering help to the surrounding population. So obviously a very negative cycle and one that we don't want to see happening. But it's one that we definitely have seen happening. So hopefully at this point you've become aware of a whole bunch of different issues now, and maybe you're feeling a call to action. And so now we can talk a little bit about, what can we do, or what is to be done about some of these things. So fortunately, EWH works in sort of 3 of 4 of these areas that we're talking about right here. So one of the biggest things that we can do on our side, if you are coming from a high resource area, or if you're living currently in a low resource area, is to educate on a lot of these needs. And this applies to all sorts of different areas. If you get the chance to speak to any sort of party who's involved in the donation process, we always really, really want to promote responsible donations. And how do you do that? How do you donate responsibly? Is by donating with education and donating knowledgeably about the areas that you're trying to send equipment to. Similarly, we really want to educate people on how to design medical equipment that is focused for low resource areas, and who are the best parties involved in that process. And so we definitely want to take engineers, whether they be biomedical or other, who are from high resource areas, and educate them on the trickle down effects of designing products that are exclusive for high resource areas versus designing products that could be much more inclusive globally. And we also really want to get biomedical engineering more and more promoted within low resource areas, so that we can have more engineers coming from low resource areas and designing products that they are going to be the most knowledgeable about. Similarly, EWH works in a couple other different ways. And finally, we want to talk about servicing the equipment that is already in the areas, whether that is donated or purchased or other, and that can be serviced by outsiders coming in, or it can be serviced by people who are trained and certified to do that in the area. So what can you as students do? One of the different ways to sort of get a hand on all of these different areas is to take part in what we call our summer institutes. And you might be familiar with this, or you might not, but these are programs that we run each summer if you're in the Northern Hemisphere. And this program is 2 months long. It's 1 month of technical and language training, followed by 1 month of working in a low resource hospital abroad. So this is actually a picture that we have of 2 undergraduate students. Both of them are from Virginia, and they are working in Nicaragua on a microscope. And so this is a perfect example of when we've had students who will go in and study medical equipment with us, and then spend some time interning in a hospital, getting to better understand all of these different elements that we talked about in the last slide, so that they can become better global engineers, or better engineers and more understanding global citizens sort of moving forward. So what does this program actually look like? So this first month that I was talking about, you will spend basically 4 weeks with us learning technical and engineering skills needed to make repairs. So we train very specifically on the different types of medical equipment that are most likely to be seen in your area and at your hospital. And you'll learn all about how to fix surgical lights, how to fix different suction machines and nebulizers and things like that. And you'll really study the operation, the function, and the design of these different medical devices or lab equipment that is most commonly found. Similarly, we will study how to make repairs when limited resources are available. So when you don't have that spare part, what do you do? What are your next steps? How do you troubleshoot to find the problem to begin with in a machine? And we spend about a month training and doing that with students before you're even allowed to go work in your hospital. And on top of that, depending on the country that this program is located in, you study the local language. So students will spend they'll spend typically 4 hours in the morning studying a local language, followed by 4 to 5 hours in the afternoon doing classroom work and lab work, all on medical equipment. And the local language is really, really important, because how are you going to work in a hospital as a volunteer if you don't know how to communicate with anybody? So this is something that is really critical in all the places that we work. And then so after you train with us on how to repair medical equipment and how to communicate and how to operate professionally in this setting, we allow students to go and do field work. And so, or this field work actually takes place in the first month as well. So you'll go out with your supervisors and you'll work as part of a larger group with either a professor or a TA, and do work for a hospital or visit hospitals and do inventory for them, or other requested work for certain hospitals, so that you can sort of become accustomed to what it's like to be around medical equipment and what it's like to be acting as a professional in a healthcare setting in different low resource areas. In addition to this, we do all sorts of fun things during the first month. So we'll do different cultural based activities and labs and things like that. Sometimes we'll do different outreach events, sort of depending on the area that we're in. Previously, we've had tons of students who would go and either, like we've had students go and do labs with local schools and things like that, and do a STEM-based outreach activity at a local school. And we've had students who have done all sorts of different cultural activities while doing their initial month of training. So this is all followed by our second month of hospital work. And so during this month, or this week period, students will actually be placed in hospitals around the country. And so this usually occurs in teams of 2 to 3 students. And students will be put pretty independently to intern and work alongside hospital staff, repairing medical equipment. And so during this time, you'll be repairing medical equipment, but you might also be developing user guides or instruction manuals for the equipment for the reasons that we talked about. You might be translating manuals or making them a lot more, you're making them easier to understand. In addition, you'll be sort of working alongside hospital staff. So some hospitals might have biomedical technicians to work alongside and learn from. Other hospitals won't have biomedical technicians, and they'll just have hospital staff or maybe maintenance staff. So there's a question in the chat that I'm going to address right now. Actually, I think it's more appropriate. The training course only offered in Virginia. No, I should have clarified. This entire course is a 9-week program that takes place in country. And so headquarters is in Durham, North Carolina, but we don't do any of the training we don't do any of the training at our facility. This is all done in country. So for example, a program that's hosted in Guatemala, all 9 weeks of that would be done in Guatemala. So the language training and the training in country. And then after your first 4 weeks of training, then you would be then you would be placed in a hospital. So it's 4 weeks of training, all in country with us, followed by basically an internship at a local hospital. Yes. And so during this process, you might work with a biomedical technician, you might not. That's really dependent on the location and on the specific hospital. So what are some of the other things that you can do? Oh, I'm sorry. I thought the slide was changing. It was not. So beyond the classroom portion, you're working as a hospital. You got the gist of what I was saying from this. But basically part of your field work is you're going to be working during that first month of training, as I was saying, and you will get some access to hospital and some exposure to hospital work during that process. But this is still during the training program. And then finally, you get added to, or then you're placed in your internship phase of it, or what we call like the hospital placement phase, which is when you are physically in the hospital with other hospital staff, working with them, learning how to fix medical equipment, and training staff, developing those user guides, translating manuals, as well as building relationships with the staff and technicians, and getting to know your local community a lot better, because that might not be the same place that you trained. And finally, you're also living and working as part of that small team that you're on. So either with one other person or two other people, and really becoming a part of that local community. So I apologize that you didn't get to see the slides along with that, but hopefully we're all caught up now. All right, and then so finally, what are some of the other things that you're doing during your time in one of these programs? Well, you can contribute to our design projects list. EWH does a design competition every year, and this is one of the ways that as a student you can sort of help pass along the knowledge that you would learn on the ground, is by contributing to lists of the needs that you see and different things that you see and are exposed to in country. Additionally, all of our teams of students complete a secondary project. So this is a project that's based specifically on the needs of the hospital that you are placed in, and it's something that you determine while you're there. So we've had students do all kinds of things. We've had students who have redesigned lighting systems for their hospital. We've had groups who have built wheelchair ramps and things like that. We've had students who have put up clothes signs, because that's what the hospital needed most, because people were outside hanging their clothes on bushes and things. So this is an area that's really specific to your hospital's needs, and it's basically a thank you to the hospital for allowing you to spend time with them and to learn from them, and to have an internship at their facility. Is a final project that your team will do during your time there interning and fixing medical equipment. And additionally, we have students who will begin projects, sort of designing equipment of their own, and begin that process for if they're hoping to innovate medical equipment in the future. They'll start learning from what they learned on their trip here. So this coming summer in 2022, we are planning on running 3 summer institutes. And these are, I'll preface by saying this is all COVID permitting, but we are planning on running institutes in Rwanda, in the Dominican Republic, and in Guatemala. And all of these will be open enrollment 9-week programs. And so each of these will be the full program training into a hospital internship. And these are sort of the 3 different locations that we're hoping to run in the summer of 2022. So some differences between these 3 sites are, number one, going to be the dates that they're running. You might find that certain ones work with your schedule better than others. But you'll also see that our first month location is going to vary depending on where you're at. So in Rwanda, it's in the capital city of Kigali. In the Dominican Republic, you're in Santiago. And in Guatemala, we start out in Shela. And there's a bunch of reasons for that, depending on which location that you're in. But obviously, depending on the country that you're in, you're also going to learn different languages. So in Rwanda, which is somewhat English speaking, you're going to focus on Kinyarwanda, which is the other primary language, as well as a little bit of French. And in the Dominican Republic and Guatemala, which are both Spanish speaking countries, you would be learning Spanish. So similarly, the housing is going to vary a little bit depending on the country that you're in. And as I mentioned before, whether or not the hospital staff has trained biomedical technicians is going to vary as well. And during this process, you're going to be supported by EWH the whole time. So you will be traveling the first month with a professor who is teaching this program throughout the year, as well as with trained on the ground coordinators. And so these are individuals who have worked in the country previously, who have worked in hospitals and have worked preparing medical equipment. And these individuals are sort of going to be your go-to people for anything that you need on the ground and in country. In addition, EWH is going to have 24-hour emergency hotline assistance, as well as staff in the USA who are on call and sort of ready to answer your questions, ready to go. And you're going to have all kinds of other technical support that you've got access to during the program. And so after the program, we've got a lot of opportunities for as well. We've got alumni specific programs. You can basically come back and work as an OTGC if you would like to. We have a super high recommendation rate. 100% of students would recommend their programs, and you can continue reading more about the programs sort of on our website. So if this is a program that interests you, what I would encourage you to do is check out our website. Applications for this program are going to be open by November 1st. So a lot of the information that we have available on the overview slide that I had up for you is all COVID permitting. And we will be making absolute final calls on whether or not a program can run this summer by January, but we're opening up applications by November. So definitely check out the website if you are interested. And we also have an interest form if you want to get on our listserv that I will go ahead and drop in the chat. But that is sort of your best way to get involved and keep an eye out on these programs is to get on our listserv, express interest in the program, and make sure that you're getting information from us. If you've made it to the webinar so far, it appears that you've got our contact information somewhere. We will also post information about the Summer Institutes on our social media, but I really encourage you to go ahead and get signed up and try and get and express interest so that we can send all of that information to you as well. And I did see a question in the chat asking about opportunities for professionals or recent grads. Yes. So as far as the Summer Institutes go, they're open enrollment. So this is not just for undergraduate students or graduate students. We do have young professionals who regularly apply and participate in the programs. If that's something that is not of interest to you, you can definitely reach out to us independently, and we can sort of talk about different ways to get involved. I will say briefly, there are right now 3 open positions at Engineering World Health. If you think you have relevant experience, you can definitely take a look at our Work With Us page because we are hiring at the moment. So I will throw that out. While that is not the purpose of this webinar, I will definitely pitch that to you all right now. So other ways that you can get involved if you are at a university or even if you're at other levels, is to either get involved with a EWH chapter at your university or start one if your university doesn't have one. So this is a really, really great way to get involved locally. Our university chapters do all kinds of things from STEM outreach to working independently with different sites and healthcare centers in other countries. And we can give you tons and tons of more information about how different chapters are involved. But this is one of the best way to sort of have local reach at your local level and to be in touch with people who are also involved with Engineering World Health and who have similar interests and ambitions is to get involved with a chapter. And that's really where you'll probably have the most active role if you're not in a program. But you can also participate in our annual design competition if you're part of a chapter. And this is an area where you can submit research that you're doing, or you can submit a proposal for a design project and win money from us basically, and be active on the side of innovating for low resource healthcare. And finally, we have virtual programs that we do every year as well. And or multiple times per year. They've started since the beginning of COVID. So this is a fairly new venture that EWH has undertaken, but we have been doing different design programs and courses for engineering students and for even high school students and individuals who are interested in healthcare or in engineering for healthcare to take part in. So I definitely encourage you to click all around our website and get all kinds of information on all of those things. So I am going to go ahead and drop the interest form in the chat. Let me pull that up really quickly. So if you want to get more info from us, just in terms of when we throw out different advertising materials and things like that, that is going to be the best place to sign up. This is our interest form now in the chat for you guys to access. If you're watching the recording later, I will also send this, we'll send it out in the following email, so you should have access to it by now. But I do want to sort of open up for questions at this time. So we got one from Jasmine that said, how many people generally apply versus how many people are accepted for the summer institutes? This is a pretty broad question. I'm hesitant to answer just because of the uncertainty of things surrounding COVID right now. We're not exactly sure what numbers will look like in terms of percentage of students that we're able to take at this time. I would say we accept a fairly high number of applicants to each of our program. Typically, we are running fewer programs than we usually do, but I would say in a non-COVID year, we probably accept around 80% of applicants. So it is quite high. We do want to get people involved in the process. We don't have a lot of reasons why we don't want to accept people. What I'll say is applying early definitely helps. We do have we're planning on having 2 application deadlines. So like, while it's not a rolling application, there are multiple deadlines. And so as spots fill early on, or by the earlier deadlines, there will become less in the later ones. And especially when it comes to financial aid and things like that, that is sort of given out on closer to a rolling deadline. So like if you're applying for financial aid from us, which is need-based, it's not merit-based, we will honestly have more financial aid to give out earlier than later in the sessions. So my advice is, if you're worried about being accepted versus not accepted, just go ahead and get your application in early. Right now, the application is not live, but it will be going live in the coming weeks before November 1st. So definitely keep an eye out, and that's a really good area to look out for the interest form, or get your name on the interest form. All right, other questions. So Mongai, I'm an alumnus from the 2018 Summer Institute and have developed interest, but unfortunately there's no school in my country that offers this as a career. Scholarship advice for biomedical engineers. I would go ahead, Mongai, and shoot me an email about this, just because that can become a tricky question. So let's talk one-on-one about that. Becoming a biomedical technician, when there's not training programs for that in your country becomes tricky. So let's go ahead and talk about that in person or over email independently. Are there any other questions at this time? And I see, Brittany, you've got a question. And if anyone else isn't able to chime in via chat, but has a question and wants to speak, you can feel free. You can either raise your hand or just go ahead and turn on your audio and shout out your question. Not a problem. And yeah, otherwise, I think we're hitting just about that hour mark, so timed it pretty well. But I'm gonna go ahead and stay on for the next few minutes. So if anyone has questions that they want answered, definitely feel free. I won't stop the call early, but if otherwise you're feeling all set, and that is all that we have to say this evening. All right, and finally, once again, thank you so much for joining. We really appreciate it. We hope you get in touch and are able to stay in contact with EWH. So